Okay, hi there. In this video I will show you how I've made this header pipe out of titanium tube, and I will show it with the tools I needed for this one, but I will also show the second one because it's a two-cylinder bike I'm building, so I'll show you how I will make this side. Basically you will go from this old header, which was 2 kilos, to this nice looking header pipe, which is only 0.6 kilos, so that's 3 or maybe 4 times the weight that I'm saving. So it's really worth the effort, and also it just looks incredible, I think. I've bought these tubes. These are, it says it on there, 38 out of diameter, 1.5 wall thickness, and I've bought these tubes online, which meant that I guess for shipping they limit the length to 1 meter, but for most bikes 1 meter is plenty. This is the tube to give you an idea. To go from straight to there, what you need first is a basic idea of a design. In my case, I made a design with the whole design of my motorcycle. So I've made a 3D render of how my header should look like. I kept it quite simple, which meant that I'm going straight into the head for about 50 millimeters. Then I have an 80-degree curve out with a radius of 100. You can see it here, I think. Yeah, radius 100. Then straight for 100 millimeters, and then another curve which has a radius of 200 millimeters, and this is for 115 degrees. So this is a little sharp and this is a little blunt. Also important to know that this curve and this curve are not in the same plane. They are twisted by 30 degrees. I will also show you how to measure this because it's quite important to get the rest of the pipe to fit. If you're not designing in CAD or in 3D, you will make, like an example, in something like a 5 or 6 millimeter steel rod. I've also made it just to check how I was doing during the bending. To make this one, I took this one from scrap bin. I think this is almost radius 100, and this is from my press drill, the one over there. And this is radius 350, but with the bending back of the rod, it kept going to radius, radius 200, yeah. So if you have this, you can bend it freely also if you want, not with this, but just like this. So if you go to the bike, you will see that if I enter the head here, then the pipe will nicely go below the engine casing out to the muffler, which I'm also going to make out of titanium. It's very important to make this. The more time you spend making this example, the better your pipe will fit after bending. I've seen some people that put a big washer on this rod with the outer diameter of the tube, just to see if they can slide the washer along the rod, so to see if they don't hit the engine casing or anything. I think that's a good idea, but in my case I didn't do it because I made the 3D design and I knew it should fit. Okay, so that's for the example. Then onto the tubes. You will need a beginning of the tube. I've tried here, it didn't work, but basically to make a flange to fit the pipe on the engine, you need something like this. Like a flange, and I've made this flange with the torch and the hydraulic press, which was very easy because I had the luck that I had this dowel, this socket, and it fits in there, and it's shaped, as you can see, like a cone, and this pushes the titanium open. I press it in here, Don't do it cold, it will tear the tube. But if you heat this edge and you press it in with hydraulic press, you will open up the tube. Once it's open up, it will be like tapered 45 degrees, but you need it completely flat. Then just take away the dowel and use the use the hydraulic press flat surface to press on the 45 degrees until you get a 90-degree flange, which is quite easy. I will do this on this side. So with the flange being 45 degrees by the socket, I will now heat it again to press it again, but flat, to get a 90-degree flange. So this is now a nice flat flange. I will insert the socket again because I've seen that the diameter is a little less, so we will need to stretch that open again. What also helps is inserting the pipe with the flange into the lath and then not milling it down with the cutting, but with the side of the one, because then you are just rubbing it, and like this, any misalignment can be taken out. Okay, so now I've aligned the flange in the lath to make sure that this is perfectly perpendicular to the length of the tube, which is important because it determines the way your tube exits the cylinder head of your engine. So if you follow a certain shape, you need to be sure that you are starting with a nice flat and level surface. Now I will press this one in there. It's 35 millimeters, which is the inner diameter of the tube. Because of the pressing of the flange, it got a little more narrow here. I will press it open with this one, but leave it in, because it will also act as a stop if I fill the tube up with sand to start the bending. Also, this serves as an inner reinforcement when I'm clamping the tube from the outside in my bench vise, because if there would be nothing inside, I will just press the tube flat, but with this one inside it will not work. So I will first heat it up a little more and then go to the press and press it in there. Like, I'd say 2 or 3 centimeters is enough. The first 50 millimeters of the exhaust header are straight, but if you press it in 50 millimeters, you also have to pull it out 50 millimeters, which is kind of hard. But it will take away a lot of the heat, because your bend will start here. You will heat this area to make the first bend, and this one will eat up all the heat. So if you only keep it in the beginning, that's enough. So like 2 or 3 centimeters in there, that's enough. Okay, so now that we've pressed this solid piece of shaft into the first few centimeters of the flange we've just made, we can work on the other end. There we need to temporarily make some kind of a screwing closing thing, because we need to fill sand from here and also apply some pressure on the sand. To do this, I found this really big bolt I was lucky enough because the key size was 35, which matches the inside of the tube. So I put this into the lot, turned it down to 35 millimeter diameter, then made two tapped thread holes in there, so I can insert it in here with two screws on top, and then I can open the bolt, the big bolt, and pour sand into the tube like this. The sand that goes into the tube needs to be very, very dry. I've just bought dried sand. I think it's used for tiling and stuff. So you just pour it into the tube. The tube seems to be full of sand, but with a rubber hammer I will tap the sides to make the sand lower itself into the tube, because we need to be really sure that it's as full as possible with very little air pockets. I've made this to clamp the tube, which is basically hardwood. I wouldn't advise pine or some lighter kind of wood, because as you can see here from using the other side, it gets quite hot and you need some massive solid kind of wood. I drilled a hole with it. With this one I had the luck that this was 38 millimeters, so the core is garbage. And then after cutting the hole, I cut it in half with my miter saw, and then I ended up with a nice and easy clamp like this. This clamp will now go around the neck into my vise, and now I will tighten the bolt that pushes the sand into the tube. I did apply some grease on the threads, not too much, but some grease is always easy to tighten this kind of bolt. You will get a lot of pressure, but when you start tapping it again with the mallet, you will see that it gets easier to turn it again. We can start with the setup to bend the first curve. You will not take the clamping end, because that's the loose end. You will take the end that will go into the exhaust port of the engine. I will take my clamping blocks around and put them as close to the header end as possible, like so. And then I will put them into my bench vise. Which is very important, is that you put the tube nice and level. You take away this plastic sleeve. It needs to be very level, because this will help you to make the bend nice and flat. It needs to be flat in the same plane. Okay, so that's nice. You will have to clamp this one with all the force of your life. Okay, that's fine. Okay, and then you've probably seen this kind of wood here. This wood is basically a setup on a sawhorse, like this. And I will use this one to guide my bend. So this beam fits just below the tube. So when I'm bending, I will bend like this and keep this one flat on this piece of wood. Otherwise you might make your bend go down and maybe go up again a bit later, which is not so good. My first bend on the motorcycle was without the wood, and as you can see, it's not perfectly flat in the same plane. It's going like this and then like this again. It's not that bad, but still you see it. So that's why I will do this with wood this time. Okay, and before I actually start heating, I did mark the beginning and the end of my curve. This distance I was able to configure with my 3D program, because this is the exhaust curve and this is the center line of the exhaust. So I know with the length of this line, which is 175 millimeters, that I know that the bend length should be about this. This is also the radius, which is 100. And to check the radius, I have this tube, which is also 100 radius. And I also have my example, which is also 100. And to check the angle, because I can make this bend like this or a lot steeper, I know that I should end up with 80 degrees. This one is just a cheap one from AliExpress. Couldn't get any better. It's perfectly for what I needed. So right now I'm ready to bend. I will keep this end on the wood during the bend, and I will start heating, but I will only heat the outside of the bend. Okay, I'm now not finished, but I will just show you where I am. As you can see, the bend is quite uniform, which is the most difficult part, according to me, because you need to heat the whole length of the tube. If you only heat one part, it will bend more there and the rest will not bend. So in order to get a uniform bend, you need to heat it everywhere. Also, when you're heating a little bit more here, you need to come back there once in a while to keep it heated up. Now I'm not heating, which is not good, of course, but I will recover that quite okay. So you only heat this side and maybe a little bit upwards and a little bit downwards, but you only need heat the gray side. You can also heat this side a little more because it takes more heat away to the rod you've inserted, and also of course the wood clamp takes some heat. You can see my marking from the end of the bend and from the start of the bend, and now I will finish until I got 80 degrees according to this. I'm done. I'm at 80 degrees. I cannot measure like this because it's too hot. But when I hold it here, and then I measure from the end of the tube to there, and from this end of the tube to there, plus or minus the wall thickness, I see that I'm parallel like this, and I know it should fit. Also, my example, which is this one, fits on top of it, as you can see. Now I'm set up for my second bend. As I've explained, I need the first bend to point up by about 30 degrees. Then I have a straight end of 100 millimeters. I did clamp this piece of tubing here to make sure that this is rigid until the start of my bend. Then I will bend along this length. I marked it down, so I need to heat from here to there and everything in between. And I will bend the end over this flat plane of wood to make sure that I'm keeping in perfect horizontal plane, which is 30 degrees offset to the first plane. So let's start heating. So I'm done with the second bend, and as you can see with my digital angle meter, when I'm touching here and touching there, I'm at 114.6. I meant to be at 115, so I'm only 0.4 degrees off, which is quite okay. I'm sure if it doesn't align with my muffler, I will manage to just stretch it out a little. The bend is quite uniform. The only thing you see is that the tube has been sagging a little. I guess this is because of the heat. Maybe it would be better to have something supporting the tube here, but it needs to be steel since we're heating there, so the wood is not an option. Or instead of using a horizontal plane for bending like I did, maybe you could turn it vertically up, and like this you won't have to accommodate for gravity. Maybe that's something to learn for the next time. But maybe if we have it in the motorcycle, it's not even noticeable. We'll see. I will fit them onto the motorcycle now, but first I will have to get this bolt out, drain all the sand, pull this one out. This might be a little difficult, but I applied grease. I hope it will work to just wiggle it out with bench vise, and like this our header pipe is done. So I've laid out both of my headers on a flat surface, being my welding table. I made sure that they are level and they are clamped to a 90-degree edge, so they should be exactly the same, but as you can see, it's not like this. I made this one first. I tried it on the motorcycle and it came out pretty good with the end here. So I will follow the first one and readjust the second one I made. Luckily the sand is still in there. And I will bend it a little more. But as you can see here, the front of the bend, so the second bend was more or less spot on. It's more like the radius that has quite a bit different radius. So as you can see, I made a much tighter radius on the first one. So I think I will have to get this bit a bit more tight. So I will have to re-warm this and then bend it again. For, yeah, it's kind of hard to tell, but I'll manage to check, for example, measurements from here to there, and then I will measure here, this one, and measure it on the other one as well, and then I have some points to work on too. This is my motorcycle with both of the headers installed. I did a final check, and where you can see both of the pipes along each other, they are quite equal. Also here you can see that the air gap in between is perfectly the same. Also my level is stating more or less the same, 7 degrees on both sides. You can also see here on top. So I will cut them off somewhere here and then start the muffler, but I'm really happy with the result. It looks amazing. These are flanges I had laser cut, 10mm aluminum, and they just bolt onto the original studs. These holes are for weight reduction, heat dissipation, and then after these are my aluminum halves that push in the flange. They push in the titanium flange onto the exhaust gasket of the cylinder head. So that's all.